Hey guys, this video is way overdue, but tonight I'm going to talk about 3D printed computers. So let me start off by giving you a visual clue. On the table in front of you, you see two rows of computers, an upper row and a bottom row. And one of the rows, the average age is about 30 years old, and the other row, each machine is less than 6 months old. So I'll let you think about that, and we'll get into the details here eventually. So as background, about 2 years ago, I bought a 3D printer. It's Bamboo Labs P1S. And at that time, I knew nothing about 3D printing. So I set it up, learned how to use it, learned how to download STL files, eventually got a personal use version of Autodesk Fusion 360, and began creating my own step files, my own solid files. And at first I printed off little pieces, bushings or brackets or whatever. And a lot of it was to attempt to reproduce or repair parts, from my vintage PC collection. And as time went on, I said, I wonder if I could 3D print an entire case. And again, that's targeting the heart of my collection, which, as you can imagine, it's the Beige early to mid 90s Minitower, mid-tower type PC. That was ubiquitous with the 386, 486, and early Pentium era. And as I did my research, I determined, at least with my printer, it was very unlikely I was going to create a case that's going to accommodate the traditional AT type motherboard or baby AT motherboard. It wasn't going to be practical with as small of a printer as I have. So I said, well, all right, what can I come up with that is shall we say, a facsimile of that type of computer? In other words, something that looks like it, acts like it, feels like it. It's not going to be a 486, but it's going to be something that looks and feels that way, and in particular can accommodate real hardware, like real 5¼ inch devices, 3½ inch devices, and have the look and the feel, the rocker switches, the momentary push buttons, the 7-segment LED megahertz indicators, the rectangular or round LEDs, something that looks like cases did 35 years ago. So I found a project on the internet, which I'll post the link to here, that was my starting point. This person had quite a bit smaller case, but it had excellent fundamentals. It was able to support an ATX power supply, a Mini-ITX motherboard, a single 3½ inch device, I had a drive bay for that, and it could be printed in pieces and then assembled. And the pieces were small enough that any available 3D printer could print them out. So I downloaded the project, printed it, put it together, and I was impressed, but it wasn't quite what I was looking for. So I spent about 1.5 years re-engineering that chassis and getting to what we see in front of us, where we have two 5¼ inch bays, two 3½ inch bays, and then lots of real estate to place the classic features. The buttons, the switches, places to put stickers and badges, LEDs, and so on. And I got to the point where I have a standard chassis, and really what differs is the front fascia and the switch arrangement. That's kind of the sculpting of the front of it, if you will. And at the same time, I was able to source a fair amount of new old stock, classic hardware like the rocker switches, the 7-segment LED displays, and so on. And I'll get into those details in a minute. But this is just the intro here to let you know what I've been up to. I think we'll have a good time going through the details. In the next couple of video clips, I'm going to go into quite a bit more detail about how these 3D printed cases, what they consist of, and how they go together. So what we have right now in front of us is a side-by-side of an authentic 486 Minitower PC on the right and my 3D printed machine on the left. And dimensionally, the most significant difference is the depth. A standard AT case like we have on the right is about 16 inches deep, and my case is about 8.5. Now, it is deep enough to support the vast majority of 5.25 inch devices. This is the case fully disassembled and laid out. The case consists of 12 primary structural 3D printed elements. The front fascia is actually two pieces that are printed separately and keyed and glued together. And then this is the cosmetic roof and floor plate that each fastens on to the top and bottom of this front fascia, and it's its own subassembly. And then these four components comprise of the core. So when they're fastened together, they support the ATX power supply and the Mini-ITX motherboard. And then these four panels here consists of the side panels, and they fasten onto this core assembly. And then the upper side panels actually have bosses that protrude inward, and this is where the 5.25 inch devices fasten through with long fasteners. This is an example of what I put into the 5.25 inch space on this machine. This is a standard IDE CD-ROM drive, and this is a 3D printed frame that accommodates a SD to IDE drive converter. This is a sled that accommodates the two 3.5 inch devices. In this case, I have a 3.5 inch floppy, I've got a filler plate, and this slides into the rear of the case, rests on the front, and then locates and then fastens on the rear sill of the case. In the case of this front fascia, there's a ATX momentary power on and a reset button. And these are commercially available keyboard switches that are encapsulated inside this frame that then mounts to the rear face of the fascia. In other designs, you can add other accessories. This is a classic rocker switch that you would find for the 386, 486 era mains disconnect AT power supply. And then this is an example of a 2-digit 7-segment LED matrix with jumpers that allow you to set whatever megahertz display you want. And there's a total of 35 M3 fasteners that hold this together. You can see these heat set brass fastener nuts. This particular unit uses an EPIA SP motherboard made by VIA. So this is a 1.3 gigahertz VIA C3. This is a great arrangement because the CPU and the bridges consume about 15 watts, which is ultra low power and great for this type of design. It uses DDR memory. I think this is a 256 megabyte PC 2700 DIMM. It's got a PCI slot. It's got dual IDE channels, dual SATA channels, and then it's got the legacy PS2 keyboard, mouse, VGA, RS-232 serial, USB, LAN, and then I think this is S-Video out and composite out, and then it's got a audio codec, which I believe is AC97 compliant. But what's great about this board is it supports DOS, Windows 98, and XP very well. In the case of DOS sound, I use either SBEMU or VSB HDA. It works great with this audio codec. And then for example, if you're going to do any kind of packet driver services under DOS or IPX type gaming, this is well supported. And then obviously for 98 and XP, this is fully supported as well for that environment. There are other boards that you can use, other flavors of the EPIA boards that have, for example, an actual floppy drive interface. In the case of this board with that floppy, I would use a USB to floppy converter and actually go right back into the rear of the motherboard here. So next I'm going to show you the assembly of a similar case so you can see how it's done in kind of a time-lapse manner. Let's talk about controls and front panel power. You're probably wondering how we connect that to the motherboard. So let me do a quick partial disassemble on this. First thing I'm going to do is remove the 3.5-inch sled. There's that. I don't have all the screws in on this one, but just a few. Okay, so the front fascia and the roof and the floor plate are a sub-assembly, so they'll slide right out. Let me flip this around. Okay. So what we have here, there are 3 physical momentary switches: ATX power, reset, and this button does nothing, but it looks good and it may have some future use. And then I've got the power LED, the sleep LED, and the hard drive activity LED. So what I use are these DuPont wire pairs you can get off Amazon pretty cheap, and they have a variety of DuPont male, female. You know, some are the 1/8 inch or the 1/10 of an inch, which is 2.54 millimeter spacing, and then others have the 2 millimeter pitch, and that's what the rectangular LEDs have. So I've got basically color coordinated bundles, and right now I just have some black PVC tape wrapped around the junctions where you can pull them apart, but ideally I might have some kind of a locking clip, but for now this works. So if I do have to completely remove this front assembly, I would just take the tape off and then pull the junctions apart. And then all of this goes to the front panel header on the motherboard, which is down here, kind of out of sight. And then in the case of the megahertz LED matrix, that just takes a 5 volt and a ground. I'm tapping that off of the bird connector for the power supply. So as you can see, you can take this front cover off reasonably well. Now, if I were to go as far as to remove the side screws on both sides and pull out these 5 1/4 inch devices, with just a couple of screws, I could take one or both of the side panels off and get more direct access to the motherboard, and this core structure on the other side would keep everything together. It's not that big of a deal. So this thing is pretty serviceable. I'm going to take some time to talk about the design features and the overall inspiration of the machines I've made so far. So the machine on the right is probably recognizable as one of the most quintessential 486 era Minitower case designs, or front face designs. I literally went through Computer Shopper magazines and looked for, you know, what's cool, what was popular, what do I remember from that era, and that one came to the top. What's unique about this particular case is I was able to take the sketch for the control pod, you know, which includes the 3 buttons, 3 LEDs, the megahertz matrix, and then the badge recess. I was able to take that sketch, export it as an SVG, and then bring it into Cricut Maker Design Space, and then print a clear colored vinyl label, and then use a CNC cutter to actually cut it out and cut the holes and so on, and then that is stuck into the recess around the controls. And the machine on the left is the same way up in the upper left-hand corner. Now, if you notice, what's unique about the machine on the left is it's kind of upside down. And that was actually a not so common case you could have bought back in the day. And it was literally a case that was upside down with a few rearrangements. So in my design situation here, I did have to make some custom side panels, because when you flip a CD-ROM upside down, its screw holes are not in the same elevation relative to the bottom of the case, so I had to make some custom panels. Same machine's flipped around now. So the machine on the right actually has a VIA EPIA M2, this M Roman numeral 2. And what's neat about that board is it has a built-in floppy drive controller. So in this system, there's actually a connection between the floppy drive and the motherboard, and the drives are all IDE, ATX power supply. The machine on the left was a flirtation with SATA and the Intel Atom processor. So this is a Foxconn OEM board, and everything is SATA. What's neat about this board is the audio codec works really well with VSB HDA, which is a DOS emulator for like Sound Blaster Pro, and it allows you to point at a sound font file, a SF2 file. In this case, this one is using a 24 megabyte Sound Canvas 55 sound font. So if you use General MIDI and DOS, this really sounds nice. Next up are these two machines that both sit on pedestals. So this was an experimentation with I'll say mid-90s era cases that had pedestals. The one on the right is more of a truncated pyramid, and the one on the left is kind of a trapezoidal from the front view, extruded backwards. And if you look at enough old AT cases from that time frame, you'll see these pedestals. Both machines flipped around now. These machines were also an experimentation with SFX power supplies. If you notice, they're quite a bit smaller and more compact. And the reason I did that was to make more room for a riser card, for say an auxiliary PCI card. If you notice, the machine on the right has a extra sound card inside of it. So that's a right angle PCI riser card. The sound card is actually a Creative Labs SB128, which has relatively good DOS sound support compared to most other PCI cards, and it has a joystick port. The machine on the left is another one of the Foxconn OEM Intel Atom based boards. All right, folks, that wraps up the introduction to this project. So the next question might be, where are the STLs? Where can you download them? They're not in the public space quite yet. I've got some loose ends to tie up in terms of technical details. I'm looking at maybe some alternate materials and some recommendations on painting and resin sourcing. So there are a few things still yet forthcoming, but be patient. This will eventually be in the public space, and I really look forward to everyone enjoying this. So stay tuned. Thank you.